Welcome to today's iteration of the Treff. Today's Treff will be held by Florian Reinert, who will talk about metal shaping. He has quite some experience in this. Without further ado, Florian, the stage is yours.
Okay, thank you. My perspective was this year on Kolbermoor. I'm a young blacksmith. I started blacksmithing this year. So when we met at Kolbermoor, it was with Patrick. Very nice, very sweet to work together. And to be honest, it was for me like sixth coal fire in my life. So I had a little bit blacksmithing experience, and so we had a great time, and I love blacksmithing. But we came very soon to the experience. Patrick was rolling his eyebrows, because I was not understanding. So let me introduce myself. I'm Flo. Um, I come from another section. I started as a dentist and came from one to another to blacksmithing, car related, because you need some money. Okay, this first picture shows simply at the moment I'm making holes in expensive car bodies for rich people. So yeah, what's the background? So it's no problem. You just cut a hole, and so we come very soon to the problem that was on my mind. It's never a problem. There's always a solution because I love it. And the difference from blacksmithing to metal shaping is like, to me, different world. I have big respect. I love it so much. And the thing is, what I do is cold forming, is stretch, shrink, bend, cut, next is fuse to get to a panel. Okay, on this is ridiculous because I choose it wisely, maybe to get a start. It's just to cut a hole um, at a nice position and turn the edges. Okay, so far so good. This is me at a bad job. This should be the result because you can do this at any spot, but it should be aligned. So next is precision. The way people choose it later or um, look at it, you see it's just a drill. So somebody says, I want to have a 3 or 3.5 or 4 millimeter gap. They do want it. So this is all correlated my work. Sometimes I have to redo things other people did, but I want to come to another thing. This was my start. And this was planned to show this down in the workshop because this part is still available, and how to tell the people why it's so important and what's the difference from metal shaping to blacksmithing. On the metal shaping, it's very likely and often it happens very much. You choose control zones. So on this, you see on this post, on the upper side, it's just rectangular. And this was planned to show this by hands, holding this panel by hand, but it's not possible at the moment, sorry. To show what happens if you stretch or shrink on the in or on the outside. So you can control, let's say you have just a stripe of paper folded 90 degrees, and on one flange you start to stretch or shrink it. If you stretch it, it goes inwards. If you if you shrink it, it goes inwards. If you stretch it, it goes outwards, and you come very quickly to the moment you can go 3D, three-dimensional. So this at the first moment is maybe not guiding, but this was my start. So you start metal shaping out of a flat panel, making a three-dimensional object and how to control it and how to make it happen. This was made only by paper, by a drawer, and the accuracy was about below 1 millimeter. So this was my start. This is all handmade. And this is my ambition to make metal shaping, not the simply panel beater. You need to study the object and what are the steps you're going through. And next, again, it's always shrink, stretch, bend, cut. Next is fuse together by rivets or by welds. Weld is always made by butt. This is essential, no matter on what you start, if it's on steel or on aluminum. Welding by butt is essential, by TIG or gas welding. Okay, this is just, yeah, this is just schooling. So because it is not possible to bring you the input of shrinking, stretching on this last panel, because I cannot hold it in my hands. This is just the last moment to come from the cut to a round, because this heart is just, it's a funny piece because it was only made by cutting a rectangular edge, and it did create it by itself. Next, I want to show you why it's so important to shrink. Because I already told Patrick, you can do control panels not only by panel beating, stretching, or what I love very much is the wheeling. This is my absolute personal love tool and instrument, but it's again, it's always stretch, shrink, bend, and cut. This instrument, if you see it now, it's just it's powered by your foot, and you push your panel into this, and you see the slot inside. The upper press together and just create a shrink. Other side, you can do this very good by hammer. You can use its downside in my workshop, sorry. It's a tucking fork. It's like my two fingers. You place a plate of paper between it and you create a fold. So this fold, it's like a shrinking situation, but next is you have to pull it down. The power of shrinking is shown by this heart. I made this like for it was just for my mom. It's a silly thing, but it's made not by hammering, stretching. It's like a cutout heart, and on the outer sides, on the rounds, I did start to initiate a shrink, and the shrink did blow off this material that much. What you see. So want always to tell them, on the metal shaping, you have control zones. You can control an inner panel by controlling the outer side. And maybe it makes no sense, but imagine on this heart I made for my mom, it's blown off. It has a deep of maybe 1.5 inches, and it's stretched, but it's made by shrinking the outer side. I told Patrick already, imagine you work with leather. You have a round plate and you want to make it like a bag or a bubble. What you gonna do to have it on the first moment to make it happen? You just have a round plate. Think of a CD compact disc, and you implement on the outer ring just like a rope you can put together. And if you initiate a slightly bend, you can get it back. And this is really, it sounds crazy, but this is what happened on this panel. It's really, you see the hammer on the outer side, but it's really, I'm not kidding with you, it's made by shrinking to stretch the inner. So you can really control on metal shaping the panel by other zones. So I call them controlling zones or comfort zones. Comfort zones is like an overdue you need because later you need to cut it. But I need to proceed to come to the point. This is another thing, a rose I made for my mom. It's same. It's 1.2 millimeter steel. Later, I did use heat only for colorizing. Any leaf you see is made by shrinking, not hammering. This is another way of shrinking. You see, this is the round thing is a lamp section from a car. This is a Cobra 427. And this was on my start. You see this tux. I cannot tell it better. This is how we call it tux. You see lines. This is very important in the metal shaping to keep yourself visible and find orientation in what you do. So this is the crazy lines. But what I want to tell you is this inner tux, what looks like a crazy thing, this creates the round. And imagine this panel was flat before, and only by making it this tux, this is not hammered. This is like, imagine I place a piece of paper in my fingers and this way and this way, and the tux are created this way. And maybe you can understand this on this funny picture. You see? You see, this is the same panel wrapped over my head. And on the left side, there's this tool I used for making this tux. And this created this round. There was no force involved, no bending, not ever. Only this information on this tux made this panel this way. I'm not kidding. Okay. Next we come shrinking, stretching. I did hope very much to show this you very much better on this first panel, but it's not possible at the moment. We come to the wheeling. Wheeling is bending, stretching, but you can shrink too. Okay. This was in England with Andy Kissack. This was really my absolute start to another world. So it came very quick to another thing. How to copy a car section, okay? You see, you need all this. You see these lamp areas. This is a very crap result. So I choose wisely because no one can share it, this picture, but it shows it's possible to do this at home. These implements, later you can ask a lot. There are a lot of errors. Yeah, but it's possible, okay? It's the same. By the way, I did this object about 16 times. And this is about my start, third or second. Now you see sections can be curved, reversed curved. They have tucks, they have inverts, and it can be very quick, very complicated to make it to one panel. On this, you see, anyways, I already made some panels. You remake maybe some panels you do not like. This was, yeah, the intersection I like to redo. This is on the aluminum, a gas welding, and it differs very much to the steel constructors or regular things. I need to tell this. This is aluminum. This is my welding, gas welding, butt welding on 1.2 gauge, 1.2 millimeter gauge, using flux. And on the metal shaping, it's very important to not sand or grind it off with the flags, angle grinder, or whatever. It's more important to bring it together. So there's a hammering technique to bring from one side to another side, another side, another side, another side. So you can compress on soft materials and it gets flat like this. It's not sanded. This is only steel wool you see, and I had to use this steel wool to remove the flux. So it's really, I never lie, it's an honest picture. It should be like this. This is the situation on metal shaping. You weld not clamped, freehand. Usually you have one point, this is clamped. Okay, of course, it gets hot. This is the situation. You make one point, you go start your travel. Next is fusing. This is a funny situation for me to have a dial-in again. It was at night on my outside terrace, how you call it. You see the flame is for steel workers. It's a no-go because this is aluminum. This is a slightly carburized flame. On this situation, you see below, there's an anvil with only on a little tiny point a clamped piece. This is just a test piece to dial in again. And there's on the right side, there's flux. So next what I do is, you see on the right side, there's this tiny clamp with this tiny panel. You start to do welding freehand. You have a first contact point. You know it's accurate because on the next the template and template situation, guiding situation to make it accurate is another topic. But this is the crazy situation. A steel worker would say, "Oh my God!" But this is normal on metalworking. This is the result using flux on aluminium 1050s. It's pure aluminium. It looks like a shit piece because there are a lot of TIG welders saying, it's nonsense. This is another thing I made. It's just a free hammered thing, another free hammered thing. And yeah, here's the result. This is how it should look, really with no sanding, grinding. Maybe if it's a complex panel on a complex situation with two different panels, you need to planish it. But if you make a training just on a butt welding, it should look really like this, or you get in trouble. Again, this is a funny experiment on metal shaping, aluminum freeforming with no plan. This was the same situation. Yeah, this for me was like, again, for my mom, copying the nature. This is aluminum, but this is honestly only stretching by hammer and a little bit finger folding. This is because why my glasses got broken. You see again, it's only have a very good template because this was my ambition to start with it. Most essential is 85% of preparation. And templates, sometimes bugs, jigs, or wireforms are essentials. This was made free because my glasses were broken and I still had the glass, but not the frame. So everything works. This is another fun project. This is if you come from the hammering to the wheeling, one of my most complex panels I ever did. It's very lovely to do. And the reason to do it was a control panel because this is a pre-A Porsche 356 and made by Reuters. And someone did ask, I have a raw steel panel. It's truly original. Can you make me control gauge to put on a painted Bondoed car to see how much Bondo, very crazy situation, but the panel is very complex, very nice to do. You see it here again. And you see the steel original body. This was another guy who came from a Mercedes museum and told me, yeah, we have a car. We need one panel, but we need the other side. It's not available. Can you do mirror it? But the car was not at home and he gave me only wrong side. So this is 1.5 millimeter steel, was possible with templates, techniques, crazy things. When you come from stretching, shrinking, bending, cutting, welding, you see this is another, I love them. This is the kids' cars. This is another stage. You see, this is the back car. And the more tinier the things are, the more complicated it gets. And this is different to anything else because you see, on the tiny curves, it's very complicated to make it happen. But on this, you see the lower one, there's a long panel. I made this with Andy Kisek. This was my master in the UK. Very amazing wheeling master. And you see there are long curves. And this is hard to control them. But next, on the other side, it's very hard too to initiate a curve on a very short panel without a hammer, because again, I am less this kind of panel beater. I started to jump the horse from the other side. I started to create panels by wheeling and shrinking with, yeah, not a, it was not too bad. Here you see myself on the travel because it's very important from my perspective, what I said now, as a wheeler starting in UK to go to Italy, because in Italy things are working different. And this is a very big respect. Again, there's no good or wrong way. Stretch, shrink, bend, cut. As soon as you come to a three-dimensional object, you see me in the church. This was modern art in Modena. These are original Ferrari body cars. And my ambition was to communicate with the people, because maybe someone can zoom in on the left side of myself. You see, there's a panel. This is only made by stretch. You see so much marks, battle marks. And next is the way to come to a three-dimensional object. Because the Afro Gibellini, a very good master, he's really great person. He's the true original and one of the guys who did work for Enzo Ferrari. And these are the originals and the way to go there. This was my ambition, to go there and speak with them. What you see there are the so-called wireforms. And this is why the team is called Scaglietti, because it's the Italian name. Okay, you see one wireform, you see it's a kind of art, and it's just made with a U-clamp, with a hammer, and projecting any simple line to the wall. This is how this is since 70 years, how it's done. I do not want to speak about times, they're unbelievable quick. This is me in the Ferrari Museum in Modena too. And you see on the difference, it's not to show my ugly face. You see on the left side, because there were some wooden bugs too. The body making, the Italian ways or French ways, they were always combined to aircrafts and boats by making. And you see on the left side, this is an art piece made out of wood just to make it happen, to create a car. So just to think over it, if you work with wood, big respect. You see, and this picture show it, it's mixed. On the other side, you can do same situation as I did to create my own things, just like I learned it as a dentist with reproduction. You see, you bring a copy and you make a mold out of it. Study the material to create a hammer form, that's all. You see, on this picture, it shows left side is wood, right side, you see hammered panels on their style beside wire forms. This is the traditional tooling. It's my property. Usually, you can do anything with it. But again, you need to have preparation on your object, like perfect templates or anything else, or you work on a jig. Basic hammers. I do not know if this plays now. Can someone say yes or not? This
Yes,
is
it's
absolutely
playing.
masterwork. Not this is in Modena by the master Afro Gibellini and personal worker for Enzo Ferrari back in the days. And you see it in the middle. This shape is just made by a stretch with a lot of hammer marks, shrinking the outer sides. So there's a blow up. Please think back of the thing with the heart I told you before. Because it's not only bang, 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 bang. It's not a way. It can work. So next is, because this is what I love, is the wheeling. It's typically English way. It came up and raised up very much during the war. And I'm not a fan of anyone, but you can Google if UK or German did more aircrafts and how they did it. It's very crazy, amazing. And again, these round panels, flat surfaces were all made with this Ranala. And this is the tool I love very much. It's a big benefit to make door panels, side fenders, scoops, or a complete hood. Because imagine you cannot hammer this. This is a round to round situation and it creates an unlimited hit point situation with no actual hammer hits. So no noise and unlimited repetitive hit points with no pressure, no stretch, bending, slightly stretch, and try to create a thing same way. Please invite me. I pay you. This is my personal Ranala, and I hope I can show you some videos on how I create, yeah, a reverse curve or whatever with no hammer.
Florian, thank you for this amazing presentation. I think there was lots of things, at least to me, I had never thought about. So there has come a couple of posts to the chat, and this is like Paula said, making a beer cap is also based on shrinking.
Yes, exactly. This is typically. Thank you very much. And the beer cap, this is essential. You have a round thing, and let's say you a parallel line. You you want to bend it over, so this is your upwards, and what you have to do, shrinking, and this is exactly what the tuck does. So, but we start from flat. With this shrinking, you can control a lot of round shapes. So this is very impressive, and I'm not able at the moment. Looking forward, really, honestly, because I'm fixed on to show it better without speaking to make it more visible. Because on the shrinking, you can blow up, you can control panels, and on the next state, you go stretch where you wanted to have more. So there's always two ways you go between, and this is very amazing about the wheeling. Yeah, but
Yeah.
another thing is gently and do not force it. Another big difference from metal shaping to blacksmithing, because on the metal shaping, if you know really exactly what you're going to do and you initiate the information to the panel, sometimes you need to make one run, two runs, third run you see a little bit. On the third or fourth run, wow, it shows. But never overdo, because on the metal shaping, it's always a problem to shrink it back. And yeah, it's a different approach. It's just a different approach. So I'm looking really forward to make a panel happen that's maybe interesting for blacksmiths. And one thing was, as we discussed before, this just a round disc to make it to half of a ball. You see how to do this? Are you going to do the round disc spirally, stretch it up, bend it to make a half a ball? If I give you dimensions, so if you start analyzing the panel, you see the round disc, the diameter can be later the the circumference of it, but it's not possible by shrink or just bam 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 bang it. No. Study the panel. You see a round disc. You have shrinking zone. It goes maybe 2/3 to the inside, and another very hard shrinking zone goes just out of the seam. And please think back again, making a leather bag out of leather, out of a round disc. You only implement a seam, put the stroke, and it's done. So it's different approach. On the blacksmithing, if I see a round disc of material, let's say 5 mm, and I want to make a bowl, sorry, what to do? Cut it, weld it together. I never saw anyone on blacksmithing who's able to shrink this way to make it happen, to bring the diameter from a round plate to the circumference. You see?
Yeah.
So
Yeah.
because on the metal shaping, you often have controlled situations. They ask you, can you do this, please, in this dimensions? How do you do this?
Yeah. No, I think this is fitting fantastically with Paul's very interesting. Perhaps you could give a second presentation. I see there's lots of material for a second presentation.
Yeah,
Are there
please,
any further
please give me
questions in the meantime?
please give me requests or wants, as ridiculous they are. This is important to have a conversation discussion, because I speak too free on my mind. So the more I have a situation, not please fix my car, no, yeah, but the more I have a situation, let's make a picture of a panel. Yeah, I can guide you and speak more about how to do it, because this is the thing, not blah blah, make it happen and make it. This is always the thing. I never, sorry, a thing is I
Yeah.
never failed.
The shrinking that you did around the heart, the
Yes.
tools you used, you gave a very brief kind of gestury description of the tools. Tell me a little bit more.
The tool is a tucking fork. You can do this with anything else. Please, Patrick, tell me what is in. Yeah, exactly. But the fork should be more narrow, because
Okay.
because you need to have a close tuck. You need to have a close tuck, and next, if you work with steel, this is very interesting. You can try this. Okay, listen. As soon you come to a situation, you have like 3 or 4 millimeters. You can use a tucking fork to make like this kind of dent.
Yeah.
Next, you cool it down and you have like a V profile. And on the next is you would, where my fingers are, you would trap it between the V. Next is you would go, let's say, because I'm a metal shaper, just to have an understanding, you would just heat only the upper mountain,
This part.
let's say by torch. You have, let's say again, you have two sides coming horizontal, and there's going one upside down. And this is
Like
what it's what does shorten. And what next you have to, what you have to do is to shrink it is you have two horizontals, one of this like a mountain, and you trap it before the mountain starts, let's say with a welding clamp in any situation. Next is you heat up just this mountain and smack it down. And it would bring it together. You can shorten on any length, and you can take a stripe of, let's say, 2 inches and make this on one side and make it like a band, but it may still on the same gauge.
Right.
And this is a different approach from it sounds crazy to tell this to a blacksmith, but this is what happens on metal shaping. Yeah, and on blacksmithing, you just make it warm, bend it.
Yeah. In blacksmith terms, what you're doing is you're upsetting the material into itself by bumping it.
Exactly. And this is the next thing. If you create complex panels out of 3 materials, it's very deciding where you place your welds, where you place your cuts. And this has to do with creating them because you want to have your welds on the best spot. And this, you nailed it, is exactly this one, because the density of material is best. Because we speak about 0.6 to 1.2 millimeters gauge of material. Okay. And sometimes it's old material to new. So it's essential to find the cuts on the right side, on the right position, you see. And next is axis, because again, if you do metal shaping, you're not going with the angle grinder and just bah, 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 bah. No. You go inside with your hand. Let's say it's a fender. You go in on the inside. You apply a lot of power to push outwards. And first is you plenish it. Next is you file it with a body file by hand. Plenish it again. There is no angle grinder, and the result is a absolute stiff, flat, parental panel. And what I love very much is, in comparison to a pressed modern panel, I at the beginning I did start my cert very much because my master said once, think you would be yourself the panel, starting from the flat, where you want to be, who and where. So there's a lot of information you put into a flat panel. Think of a modern car. It depends on how you look at things and study the panels. There's a lot of information in it. And in modern cars and pressed panels, we come back to the control zones. They have not much information. Sometimes it's just from the round of the fender, the complete side fender is like controlled. You feel this or you see this, and this is a very crazy test. You can cut it. You can cut it with a snippet in any direction and fuse it together, but it's not gonna wobble. On a modern car made by pressing their control zones, but in the middle, it has no information. And this is a completely different thing when you think of the old Ferrari cars, wheeled panels, etc. Because it's not possible to have like a slightly curved panel out of 1.5 meters in surface and hammer it out. It's not possible.
Yeah.
You always need to sand and grind it.
There are, I'm sorry, but there are two more questions I would like to go off, and we're a bit short on time. And
Sorry.
the two questions are, one is from Paul Voss. If you could share the tool fork and like the tucking device you have been talking about, do you have a picture at hand?
Okay, the tucking fork.
Mm-hmm.
This is a self-made one. Because it depends again. Think again of the CD on the deepness. If you want to make from a round flat disc like a dome, you have two different shrinking zones. One is a deep shrinking zone going in, let's say about 2/3, and another one is a very powerful that's just on the outside. With this one, you cannot put that much power on the outer side because it's springy, but in the inside. This on the outside. Another one, moment. This is the most powerful one. But if you do not use it wisely, you can damage it. You see how simple. You see how simple. The most strength, just cut a slot. Turn it. Moment, I can show if there's an interest. It's nothing more. It's really simple, but use it wisely. Okay. You see? You use it this way. You create this, and you go to the other side.
Mm-hmm.
You use it. You use it twice, on one side and on the other side. This way, that way. And this is a very, very hard shrink. On steel, you need to clamp it, heat it. We call it in Germany, it's a nose. Moment.
Yeah.
What shows up? This one, this is a nose. So you clamp it beside the nose, just a slight torch hit, knock it down, shrunk.
Okay.
Right.
Yeah.
That's
yeah.
Yeah, that's
Thanks for the actual demonstration that made it, at least to me, that made it significantly clearer. And yeah, clear thanks for showing from Paul.
This way.
Yeah, no. And Aspen has the last question, I would say, for today. When and where do you use heat in your work?
By welding or heat shrinking on steel. Next is on aluminium, just to have an annealing situation. Because I work with wrought alloys. It's a different thing. But on the other side, if you work with pre-war cars or straight after war cars, they're made of bad aluminium. So there's no wrought alloy, and this has to do how soft it is and how much you can shrink it. So the more it gets rigid, the more you have to implement heat wisely.
Did this answer the question?
Yeah, and another thing is body lead, but I hate it. I hate it. applying body lead is another thing I use heat, but I really do not like it.
From Paul, again, thanks Clear for showing, and thanks Rainer for the interesting subject. Thank you a lot for this presentation. I think it has been very informative and eye-opening, at least to me.
Yeah, I love it too, because I love it. And please, thank you again. Big honor to speak here. And it's very amazing to meet all those blacksmith guys, because to me it's a different world, because there's no ego tripping. And I myself, a beginner on blacksmithing, and so I love it myself very much. Thank you very much.
First of all, thank you everyone for coming to today's Treff. If you've been liking this project, it would be very much appreciated if you either donate directly to the project, or another option is we have for some time now a sponsor, which is Beat Life into Your Forging. You might have heard of it. It's some online courses I run together with Kees. I have posted the direct link to the Blacksmith Without Borders donation Ko-fi. And there is also the link to where you can go for the courses we have. From my side, a big thank you to everyone who is present today and has been present throughout the last about 3 years of Treff's. I just noticed it today and I find it quite crazy. I would say it's one of the, at least for me, one of the good things which has come out of COVID.